All right, welcome back to Bite-Sized Chemistry. Today we're going to cover our final law, which is the ideal gas law. And this is a law that describes how a certain amount of gas is going to behave under different pressure, volume, or temperature conditions, right? It's got a completely new equation, and that equation is PV equals nRT. Now we know what PV and T are. They're our pressure, volume, and our temperature. The variables that are new to us is this thing called N, which means number. So N is number of moles of your gas. Then you have this thing called R, which is called your ideal gas constant. Now, the one that you're going to most commonly encounter is this one up here. R equals 0.0821 liters per atmosphere over moles per Kelvin. What you need to be mindful of is you need to look at the units that your gas constant is given in, because that is going to tell you what your pressure, volume, and temperature units have to be. Okay? So if I look here, I see that I have L, that's liters, so it means my volume must be liters. I see ATM, atmospheres, so my pressure must be atmospheres. And then I see K, which means my temperature must be Kelvin. And I tell you this because some of your teachers are going to get really tricky and they're going to give you pressure, volume, and temperature units that are not in liters, ATM, or Kelvin. And you're going to have to make sure you convert. All right, so how do I know if a word problem or equation I'm given is an ideal gas law problem? Two ways. The first one is if you see moles. If you see moles anywhere in your problem for gas laws, it's an ideal gas law problem. Or, most commonly, R. If you see an R value, that's an ideal gas law problem because the only equation that uses moles or N or an ideal gas law constant or R is the ideal gas law, right? So I see moles, I see R, I know I'm using the ideal gas law problem. So first thing I'm going to do is write down my equation. Then I'm going to write down my variables along the side. I can already fill out R because it's given to me in the problem as a little like separate piece of information. Then I'm going to read the problem. I'm going to fill in what I know. So this says a container holds 0.50 moles. Okay, moles is N, so I know my N is 0.50 of an ideal gas. Oh, look, ideal gas means we're using the ideal gas law equation at a temperature of 298 Kelvin. Okay, 298 Kelvin and a pressure of 1.1 atm. What is the volume of the gas? Okay, I don't know what the volume is, so I'm going to put X. All right, first thing I'm going to do is I'm going to double check that all my units are in the correct units for the problem. So my gas constant says I need to have liters for volume. I don't have volume yet, but I know it's going to be in liters. Says I should have ATM for pressure, and I do. And Kelvin for temperature, and I do. Now, like all of our problems that we've done so far, we're just going to plug in the values into the equation. So this is 1.1 times X, because I don't know what my volume is, times 0.50 times 0.0821 times 298. All right, that's a whole lot of numbers, so we're going to simplify. And so on the left-hand side, I have 1.1x, because that's 1.1 times x. And on the right-hand side, I have 0.50 times 0.0821 times 298. That gives me, if I round to the hundredths, 12.23. Right, to get x by itself, I'm going to divide each side by 1.1. That's going to cause 1.1 to cancel out, leaving me with x. So x is going to equal whatever 12.23 divided by 1.1 is, which equals 11.12. Well, what is x? We said x is a volume unit. For ideal gas, my volume has to be in liters. So this 11.12, it must be 11.12 liters. All right, that's the last video for gas laws. Congratulations, you made it through. Come back next time for another chemistry topic.